Hello everyone, this is Siddiqur Rahman and welcome to the second lecture of the fifth week. So let's start. By the end of this lecture, you guys will able to describe about the decoder. From this slide, we may learn or we may find what we gonna cover about this lecture. Such as we may learn from this lecture, such as overview of decoder and how to design 2 to 4 decoder applications, or you can say some of the applications of decoder and drawback of decoder. So let's start with the general overview. Binary decoder is another combinational logic circuit constructed from individual logic gates and is the exact opposite to the to that of an encoder. The name decoder means to translate or decode coded information from one format to another. So a binary decoder transforms n-bit input signals into an equivalent code using 2 to the power n input. Sorry, I repeat again, 2 to the power n outputs. Well, binary decoders are another type of digital logic device that has inputs of 2-bit, 3-bit or 4-bit codes, depending upon the number of data input lines. So a decoder that has a set of 2 or more bits will be defined as having an n-bit code, and therefore it will be possible to represent 2 to the power n possible values. Thus, a decoder generally decodes a binary value into a non-binary one by setting exactly one of its n outputs to logic 1. Now, from this slide, we may learn a general overview of decoder, or you can say the overview of decoder. So let's start. Decoder is a combinational circuit that has n input lines and maximum of 2 to the power n output lines. One of these outputs will be active high based on the combination of inputs present and when the decoder is enabled. Exactly. That means decoder detects a particular codes. The outputs of the decoder are nothing but the mean terms of n input variables lines when it is enabled. From this slide, we may learn a conceptual diagram of the decoder, and as we have already learned an overview of decoder, and we have already know that there are there are n number of inputs, and number of inputs should be placed in the left side of this figure, and there are 2 to the power n number of outputs which is placed or which has been placed at the right side of the figure, and there is also one input or a special type of input which named as enable input. So figure 1 represented the concept of decoder. So let's move into the next slide. From this slide, we may learn how to design 2 to 4 decoder, and we have already learned from the previous lecture, which is 4 to 2 encoder, and we get an information about what is the difference between encoder and decoder. And if you focus on the previous lecture and from this lecture, the first 2 slide or first 2-3 slide of this lecture, then you may find the difference between encoder and decoder. And 2 to 4 represents 2 represents the number of inputs and 4 represents the number of outputs. So let's start how to design 2 to 4 decoder. First step should be similar to the design of 4 to 2 encoder. So let's start for this decoder. First step should be inputs and outputs declaration. Let 2 to 4 decoder has two inputs, as we have already known these facts, which is symbolized by A1 and A0, and 4 outputs, which is also symbolized by Y3, Y2, Y1 and Y0. Second step would be or should be draw the block diagram of this type of decoder. The block diagram of 2 to 4 decoder is shown in below, which is represented by figure number 2, and one of these 4 outputs will be 1 for each combination of inputs when enabled is 1. So remember these things, otherwise you cannot understand the truth table. So from the block diagram of 2 to 4 decoder we may find 3 things. One is inputs, another one is special type of inputs, and last one is outputs. And in the left side of this block diagram we may find 2 things. One is inputs and another one is inputs, but we can say special type of inputs. There are 2 inputs we have already mentioned in the first step, which is A0 and A1, and there is also another special type of input which is named as enable and symbolized by E. Okay, and in the right side of this block diagram we may find there are 4 outputs which is symbolized by Y0, Y1, Y2 and Y3. So let's move into the next slide, or you can say the next step. Third step would be truth table of 2 to 4 decoder. Well, the truth table of 2 to 4 decoder is shown in below, and we have a special type of input in this truth table which is placed at the left side of this truth table. In general, truth table has 2 sections. One is inputs and another one is outputs, but for the decoder you may find there are 3 sections. One is special type of input, after that general input, and after that or after these outputs. So enable should be either 0 or 1. When enable is 0, in that case there is no value for inputs, which is don't care condition. You may find this by symbolized by X, capital X or small x, whatever you would like to use, there is no problem. And when enable 0 and the input is the inputs are don't care condition, on that case we get the output section is totally 0, which means since this decoder has 4 outputs and there is no value for these outputs for the condition of enable 0. When the enable is 1, in that case we may assign 2 individual binary numbers for 2 inputs, which is 0 and 1, and if we combine these 2 numbers we get 0 0 0 1 1 0 and 1 1. And we also find output section, since the output is the number of outputs is 4 and which is not active at a time, which are not active at a time. On this means the output would be or should be active. Just one output would be active for one condition. Rest of the output are deactive. So that's why you may find in output section Y3 is 1 just at once or at only one time. Y2 is also same. Y2 is also same, Y1 is also same, and Y0 is also same. So I hope there is no confusion about this matter, and you have already learned the truth table of encoder, similar kind of. So there is no problem, I hope. So let's move into the next step. And fourth step should be or would be Boolean function of each outputs of 4 to 2 encoder. From the truth table, in this slide, I have attached the truth table for your understanding how to write this Boolean equation. So I hope there is no problem for your understanding. We can write the Boolean function for each output as follows. y3 is equals to, since for y3, when the y3 is active, or you can say high, in that case, three inputs, a0, a1 general input, and enable, the special input is enable, which is also 1, and that's why we can write a and a1 and a naught or a0. Okay, and after that, when we write or wrote the equation of y2, in that case you may find a0 0, a1 1, and enable input is also 1. In that, that's why we can write e and a1 and not a0, because the value of a0 is 0, but we don't use the value of 0. That's why we invert this number and we get a naught, or you can say not a 0. And in this way we can write y1 and y naught y0. Sorry, I fumbled, so sorry for this fumbling. So y1 and y0. So we need to move into the next slide. Now, fifth step would be the implementation of this decoder. Well, each output having one product term. Well, so there are 4 product terms in total. We can implement these 4 product terms by using 4 AND gates, having 3 inputs each and 2 NOT gate inverters. The circuit diagram of 4 to 2, I repeat again, the circuit diagram of 2 to 4 decoder is shown in below. And we have already seen there are 2 general inputs, which is A0 and A1, and one is special type of input, which is enable and symbolized by E in the left side. And in the right side you may find the outputs, which is Y0, Y1, Y2 and Y3. And this is the logic circuit diagram of the 2 to 4 decoder. Now from this slide we may learn some of the applications of decoder. So let's start. Binary decoder are widely used in digital electronics systems. There are several applications of decoders, such as it is used as a binary to decimal decoder. Next one, it is used as address decoder in memory systems of computer and CPU memory location identifications. Next one, it is also used as instruction decoder in the control unit of central processing unit, which is in short CPU. They can also be used to make half adder and full adder. Next, decoders are used, decoders are also used to select different tasks for memory in microprocessor memory systems, select different devices in microprocessor, input or output, enable different functions units in microprocessor instruction, decoding, enable different rows and block of memory depending on address in memory chips. And last one is decoders are used in 7-segment displays as well as data demultiplexing. I repeat again, data demultiplexing. Now from this slide we may learn some of the, or you can say the drawback of decoders. If both the inputs are not connected, the output will not remain as 0. Instead, the decoder will consider it as logic 0 and the bit 00 will be made high. In the next lecture, you guys will learn about parity generator. That's all for this lecture. Thank you guys for your attention. See you guys in the next lecture. Till then, thank you.